This is the GMAT 41. You are welcome to our elementary mathematics class. In this class, we introduce the topic logarithms without tables. In our previous class, we treated indices and initial equation for which we used the laws of indices to solve problems. Our attention now is directed to a new topic, logarithms. But this logarithm deals with logarithms where we do not use tables. In fact, we don't use calculator. There is an aspect of logarithm known as logarithm with tables that we make use of four-figure table to evaluate the logarithm of numbers, specifically to base 10. Now take note, our interest here is logarithms without tables. To start with, I'd like us to define the term logarithms of a number. Before we move on into that, let us quickly identify three major numbers we are going to focus on in the study of logarithms. What are the three numbers? I represented them with the letter, capital letter N, the letter B, and then the letter X. What does this N represent? This capital letter N is the number itself. We are talking about log of a given number. Is that okay? Then B there represents the base of the logarithm. The base of the logarithm. So we could have something like log of the number N to the base B. And then X gives us the value of this logarithm to a given base. X is that answer, is that number which you would get if you evaluate log N to base B. But again, do you know something about X? X is actually the power of the base, the exponent, the index of the base, which will produce N for you. Which means if you raise B to the power of X, that is B raised to power X, you are expected to get what? N. We are now ready to define the term logarithm. Are you set? The logarithm of a number. That number is N. The logarithm of a number N to a given base B is the power to which you would raise B, the base, is that okay? In order to get N. And this power to which you will raise B to get N is our X, is that okay? Which means that if you have B raised to power X, like I stated earlier, you expected to get what? N. Once again, the log of the number N to the base B is the power of B, which will produce what? N. Look at this. If you have log N to base B, all this logarithm will be equal to X. This X is the power of the base B, which will produce what? N. So if you have log N to base B, your answer will give you the power of B, which will result to what? N. And that is what I tried to write out in equation 2 here. When we have this as the definition of logarithm, that goes with equation 2 because if I have B raised to power X, I'm expected to get what? N. Equation 2 is the initial equation form of this logarithm. Is that okay? Now let us take a look at something in equation 2. X is the power of B. But do you see that from equation 1, X is equal to log N to base B? Which means if I come to equation 2, in place of this X, I can put log N to base B. If I do that, I'm going to get something like this. It's going to be B raised to the value of this X, and that value of the X is log N to the same base B. Once you do this, your result will still give you what? N. Let's quickly look at these two examples we have on the board here. Is that okay? Quickly to see how we can apply our definition to solve this problem. So in this case, let's just say solution. Let's just say solution. The first case, we have log 3. That's log 9 rather, to base 3. Let's say that log 9 to base 3 is equal to X. If log 9 to base 3 is equal to X, then by the definition of logarithm, the power of the base, which in this case is this X, that will produce 9, would be the value of this log 9 to base 3. So how do we do that? It means that 3 raised to power X will be equal to 9. Then I'm going to write 3 raised to power X equal to 3 raised to power 2 because 9 is 3 raised to power 2. If you take log to base 3 of both sides, are you following? You are going to get 1, 1, and then the powers will step down. Or better still, you could simply say, cancel off the 3 from there, just like we learned from initial equation, and you will obtain that your X is equal to what? 2. Now look at the second case, where you have 5 to the power of log 8, and then base 5 again. You notice something that goes with equation 3 directly, and our result is expected to be the number 8. Is that okay? There's a 5 raised to power log 8 to base 5 still. So it's as if this 5 and log 5 will disappear. Then your result will give you 8. That goes with this equation 3 like I explained. In the next video, we're going to look at the laws of logarithms, and then we consider how we can use them to solve problems. In this video, we now want to look at the laws of logarithms. Now, besides the equation that was written in the previous video, specifically equation 3, where we had that b raised to the power of log n base b will still be equal to what? N, because that is the law on its own. Apart from that, here on the board we have 6 basic rules. In that 6 basic rules, there is still extensions of those rules, as you can see, some A and B, A, B, C. Now let us quickly run through these laws. Please take note, you are expected to have these laws at your fingertips. Know them at heart, so that when the question is given to you, it's these laws that you look at from your mind eyes, and by sending out the network of your brain to start thinking of the law that you need to apply to the problem given to you. Now let us look at them one after the other. The first we have here that log of the number 1 to any given base is equal to 0. Log of the number 1 to any given base is equal to what? 0. Take note of that. Look at an example here. You're giving log 1 to the base 10. Your result will be equal to what? 0. Of course, this answer follows from the definition of logarithm. You know, log 1 to base b being equal to 0. How do you work on that? You want to get the value here. How do we know that it's 0? Like in this case now, or in this case, to prove that, applying the definition of logarithm. If you apply the definition of logarithm, we expect that 10 raised to the power 0 will be equal to 1. And this balances, is that not so? Because 10 raised to the power 0 will give you what? 1. Which means that this is 1 equal to 1, and the equation balances. Or per se, you may choose to, okay, log 1 to base 10, you don't know what it is. You call it x. It therefore means that 10 to the power of x will be equal to 1 based on the definition of what? Logarithm. Log of 1 base 10 equal to, you do not know what it is, so you call it x. You know the definition of logarithm? That this base raised to power x will be equal to what? 1. If we say, okay, 10 raised to power x should be equal to this number 1. All we need to do, following the initial equation, this is the same as 10 raised to power x equal to 10 raised to power 0, because 10 raised to power 0 will produce 1. Cancel your 10s, you know, and then you obtain that x is equal to what? 0. So take note, the log of 1 to any base is always 0. Number 2, log of a number to the base of that number, is that okay? Would give us 1. As an example, you have log 5 to base 5 is equal to what? 1. Log 5 to base 5 is equal to 1. Just think of this. Imagine you say that let log 5 to base 5 be equal to an unknown, you don't know. Apply the definition of logarithm, then we expect that the base, which is this 5 raised to power x, should produce the number 5. Of course, you look at this is 5 raised to power 1, is that not so? And then this x will cancel, this 5 will cancel, and then your x will be equal to what? 1. So the log of any number to a given base, and that base is the same as that number, the result is going to give you 1. So can you tell me what is log 20 to base 20? That's correct, it's 1. What about log 3 to base 3? Wonderful. Now let's move on. Number 3, addition law. What is this law all about? If you are adding 2 logarithms to the same base, all you need to do is pick log to that base and then multiply the numbers. We have log n to base b plus log n to base b. You notice that the bases are the same, so you pick one of the logs. Is that okay? Pick one of the logs here to that same base. Then it's going to be the product of the 2 numbers. The 2 numbers are m and what? N. Is that okay? Please, I want you to take note of this. You can put it down just beside it in your notes. For you to apply this law, addition law, and also subtraction law we're about to move on to. For you to apply this addition and subtraction law, please, the coefficient of the logarithm must be 1. The coefficient of the logarithms must be what? 1. It means if it is not 1, let's assume you have a number at the back here. Let's say, okay, you have c at the back here. For you to apply this addition law or subtraction law, that c will come to the power of this n. That c will become power n. Power of this n here. Is that okay? As you need to move it, applying power law, which we're still approaching. So take note, the principle, the coefficient of the logarithms must be 1 before you apply addition and what? Subtraction law. Alright, coming back to our addition law, as an example, look at log 5 to base 3 plus log 2 to base 3 is equal to the bases are the same. You take note that the coefficients of the logarithms are what? 1. Is that okay? So you pick one of the logs to that base, then you multiply the numbers, which is 5 times 2. If you multiply 5 times 2, you're going to get 10. So that's going to be log 10 to base what? 3. What about subtraction law? Subtraction law states that if you are subtracting a log from another one and their bases are the same, simply pick one of the log, then it's going to be the first number divided by the second number. Log n to base b minus log n to base b is equal to pick one of the logs. Then it's going to be the first number n divided by the second number n. You can see that. Once again, notice that their coefficients are what? 1. And so I was free to apply the law. As an example, log 10 to base 2 minus log 5 to base 2 will be equal to log to base 2. Look at it. Then 10 divided by 5. And 10 divided by 5 is going to give us 2. So this will become log 2 to base 2. Look at that. And you remember, following this log here, log of any number to the same base, when the base is the same as that number, is equal to what? 1. So log 2 to base 2 will give us 1. Now moving on, the next law is power law. Power law of logarithm. Alright, what did the law state? If you have log of a number to a given base, and that number is bearing the power, there are actually two of the log there. One is power of the number, the other is power of the base. So considering power of the number, log of the number n to power a base b is equal to, we use the a to multiply the log of that number to the given base. You can see that. So look at an example there, log 5 raised to the power 2 base 5 is equal to 2 times log 5 base 5. And log 5 base 5 will give you 1. 1 times 2 is equal to 2. Now look at this. Do you know that this log 5 raised to the power 2 base 5 could have been written simply as log 25 base 5. Log 25 base 5. Then you break it down, work it out to get it to. Still the same as log 9 base 3. That 9 is 3 raised to the power 2. That 2 multiply the log, and you have 2 times log 3 base 3, which will eventually equal to what? 2. Alright, now power of the base. This time around, it is the base that is bearing the power. So what is the law? The law says you should take reciprocal of the power of the base, then use it to multiply the logarithm. You can see that here. Log of n to base b, where b is bearing power a. So I have log n to base b raised to power a. Take the reciprocal of the power of the base, which is going to be 1 over a in this case. Look at it. Then use it to multiply log of n towards the base b straight ahead. Looking at this as an example, log 9 to base 2 raised to power 3. So the base is bearing power 3 here. It's going to be 1 over the power of the base, which is 3. 1 over 3 used to multiply log 9 to base 2. Are we following? Okay, the next one is transformation laws. There are 3 of them. Look at it first. Log n to base b. You can split it into log of any number you like. You can see log of c, then to the given base there. This c, you're the one that selects it. It doesn't concern anybody. You decide the number to use. But the base will be the same as the base given to you. Then times log of the given original number now to the base that is selected. That's the base of the number you selected, C. So take a look at that one. As an example, if you're given log 100 base 10, is equal to, you can see I chose 5 to be the number. So it's going to be log 5 to base 10 times log 100 to base this 5 is selected. Then you solve out whatever you have there. Remember, it's multiplication. So let me ask, if I give you log 2 to base 3, log 2 to base 3, you can still work it to be equal to log 5 to base 3 times log 2 to base 5. Remember that 5, you were the one that selected it. Okay, the next one is log n to base b. This law is changing of the position of the base and the number of the logarithm given to you. So look at the law. Log n to base b is equal to, you take reciprocal 1 over log, change the position of the number and the base. That's interchange their position. You can see that comes 1 over log b base n. Before you interchange the position of this base and the number, you must take the reciprocal 1 over. Is that okay? Then lastly, log n base b. In this law, you now want to write both n as the number and b as the number. So b is no longer the base. How do you achieve that? It's simply equal to log, you select any base of your choice. Here now you see that log to be c, that's what I selected. So it's not going to be log n to that be c divided by log b. You notice that b was the base here, but this time around b became what? The number in the denominator. Log b base c. Take note, common what? Base. Once you select common base in a divisional form, both the number and the original base will automatically become numbers. And then you select any base of your choice. Please go through these laws, play the video over and over again, make a note of them. Make sure you learn them at heart, because in the next video we are going to start solving questions and we shall be using these laws as applied to the question we are given to solve. Alright, now in this video we have these questions we want to solve. We have to evaluate A, log 27 base 3, B, log 27 base 1 over 3, C, log 16 base 2. At the end of solving these questions, we are expected to follow the principles I applied to test the zone of proximal development by attempting these questions, log 32 base 1 over 2 and log 64 base 4. So how do we go about solving these questions on the board? I'm going to start with the first one, log 27 base 3. Now I want to get the value of this log 27 base 3. Now we do not know. So I'm going to say, let it be equal to an unknown. But all we know is that whatever this unknown is, is a number such that if you raise this base to its power, you are going to get this number 27. Remember the definition of what? Logarithm. That the log of a number to a given base will be equal to the power of the base that will produce 27. So self even asked before we start solving this. Looking at this, and then if we know by definition of logarithm that the power of this base that will produce this number 27 is the answer to log 27 base 3. What do you now think will be the result? What is the power of this 3? Let's say 3 raised to power what will give you 27. Without being told, it's 3 raised to power 3. But how do we solve this? All we had needed to do here was to make it equal to x. X is the unknown. So now apply the definition of logarithm. That this base to power x will give us 27. So we can now write, it implies that 3 raised to power x is equal to 27 by definition of logarithm. So we now look for a way to break down this 27 so that it will have the same base as this 3. This will take us back to initial equation. So write that this is 3 raised to power x equal to 27 is the same as 3 raised to power 3. If you take log to base 3 of both sides, you can apply power law of logarithm. Maybe let me show the full working on this now, because I mentioned something like what I'm trying to say here under initial equation, but I refuse to show it fully because we had not learned logarithm at the time. Look at this. If I take log to base 3 of both sides, I'm going to have log 3 raised to power x base 3 equal to log 3 raised to power 3. That is log of this 3 raised to power 3 base 3. From there, we can write, applying power law of logarithm here, the number is carrying this power x. So it's going to be x log 3 base 3 equal to, this number is bearing this power 3. So you use power law of logarithm again, use this power 3 to multiply the log. So it's going to be power 3 times log 3 base 3. And once you do that, log 3 base 3 is equal to 1. We know that 1 times x will give us x. I said, but log 3 to base 3 is equal to 1. So 1 times x will now give us something like this. Therefore, x is equal to 3. But of course, this is actually a waste of time, because from here we could have just cancelled the 3. That is the common base on both sides of the equation. Is that okay? Alright, just to show you the full mathematics here, all those two we used to say, okay, the base are the same, cancel out. This is actually what we did that led to that. So, having known that, I'm going to be fast in solving the orders. Is that okay? I'm going to be fast in solving the orders, and then we have the B question, that's log 27 base 1 over 3. We do not know what it's going to be, so it implies that 1 over 3 raised to power x. This 1 over 3, remember, it is still the same as 3 raised to power minus 1. Let me just show that 1 over 3 raised to power x is equal to 27. This implies that 3 raised to power minus 1 times this x will be equal to 3 raised to power 3. If you work on this, you're going to get 3 raised to power minus x equal to 3 raised to power 3. Once again, you can do that, but like I said, it's a waste of time. You can simply cancel the 3, that is a common base, and then get that the value of x will give us minus x equal to 3, and the value of x will be minus 3. That's our answer. Alright, the C part of the question is log 16 base 2. Do you see clearly that the answer to this number will be 4? Alright, to this log will be 4, because 2 raised to power 4 will give us this 16. Okay, so let us say it's equal to x. Then we do 2 raised to power x will be equal to 16, which implies that 2 raised to power x will give us 2 raised to power 4. 2 raised to power 4 will give us 16. What happens here? The bases will go off, therefore x is equal to 4. So this is the solution to that problem. Use the principle to solve these two questions. And now we've got the second question on the board. We have to simplify log 81 base 9 plus 2 log 16 base 2 minus 3 log 27 base 3. At the end of my solving this question, you are expected to test your ZPD by simplifying 1 over 3 log 27 base 3 plus 2 log 9 base 3 minus log 243 base 3. Now, how do we approach this question? Log 81 base 9 plus 2 log 16 base 2 minus 3 log 27 base 3. It's a simple one, but we can actually get the answer of this even without writing anything. We can work it out with our brain. For example, this 81 is to the base of 9. And I ask myself, is there a way I can break 81 into 9 raised to a given power? Of course, 81 is the same as 9 raised to power 2. What can really help you to know the nth power of a number? What can help you? LCM, lowest common multiple method. So that's the knowledge you use to get the n power of something. 81 now, to divide it is 3 into 81, you get 27, 3 into 27, you get 9, 3 into 9, you get 3, 3 into 3, you get 1. So there are 4 3's that actually divided 81, and those 4 3's is the same as 9 raised to power 2, because 3 times 3 give you 9, the other 3 times 3 give you 9. How many 9's now? 2 9's, so 9 raised to power 2. You know all these concepts, okay? Fine, let's come back to this. This can be written as 9 raised to power 2, and if it is 9 raised to power 2, applying power law of logarithm, it will become 2 times log 9 is 9, and log 9 is 9 is 1, so this term here is actually 2. Come over here, 2 raised to power 4 will give you 16. That power 4 will multiply these 2 behind using power law of logarithm. You'll be left with 8 log 2 base 2. Log 2 base 2 is 1. Remember, log of any number to the same base, that is the same number as base, you know, is going to give you 1. So eventually this term is 8. If you work on this term, you are going to get 9 from there. And say if you have 2 plus 8, 10 minus 9, the result of this is actually 1. Okay, having said that, let's solve this out and see. I can break this as log of 9 raised to power 2 base 9. Take note, why I chose to break this into 9 raised to power 2 is because of this base 9. If this base were to be 3 or so, I'll be breaking this 81 to 3 raised to power 4. So remember that. This will be plus 2 log 2 raised to power 4 base 2 minus 3 log 3 raised to power 3 base 3. And so you notice that each of the numbers in each log there is bearing power. So you can apply power of the number. And that's going to give us 2 times log 9 is 9. Then plus 2 times 4 log 2 base 2. Then minus 3 times 3 log 3 base 3. I've used the powers to multiply the logarithms from its back. So let's see what we're going to get. This is equal to, okay, let me still show up workings. We're going to get 2 log 9 base 9 plus 8 log 2 base 2, then minus 9 log 3 base 3. So we're going to recall at this point that the log of any number to its base is equal to 1. So this will now give us 2 times 1 plus 8 times 1 minus 9 times 1. Alright? 9 base 9, 1, log 2 base 2, 1, log 3 base 3, 1. And so this will now produce 2 here, 10, and 9. And this is equal to what? 1 if you work it out. Conclusion, log 81 base 9 plus 2 log 16 base 2 minus 3 log 27 base 3 is equivalent or equal to 1. And of course, we've obtained the answer to this problem. Use the same principle and solve this. As a hint, break down these 2, 4, 3 to its base. Use 3 to divide these 2 and see that you get 3 raised to the power 5 to be equal to 243. So you can work it out. On the board here we have the third question. We are to reduce the expression log of square root of x squared minus 1 plus 1 over 2 log, open bracket, open another internal bracket, x plus 1, close the first bracket all over, open another bracket, x minus 1, close it, then close the whole expression there, you know, to a single term. So we have to reduce this to a single term. How do we solve this problem? It's a simple one, irrespective of the many things you have there, x and x and x. Alright, now this is the expression we have to reduce to a single term. So what do we do? B is equal to, the first thing is to change this root power to fractional index. Is that okay? So this is going to be log x squared minus 1 raised to the power half, and then plus, why not we quickly move this 1 over 2 to become part of this number here, so that the coefficient will be 1. Remember I told you when I was explaining addition and subtraction laws of logarithm that for you to apply these laws, you know, the coefficient of the logarithm is expected to be what? 1. So I can quickly do this log, then brackets, you have x plus 1 all over x minus 1, then all raised to the power 1/2. Now the logarithms are on the same basis. They're the same basis. This is not like the previous question we solved where I chose to break down each of the terms. In fact, in that previous question too, I could have chosen to use both addition and subtraction law there because we have plus and minus in that expression. But I saw that it would be easier to break each term down. That is why I went that way. You may on your own try to use addition and subtraction law, then you get the same result. But this term, we must have to use addition law of logarithm. We cannot break the numbers in front. The terms in front are a bit complex because they contain x. Therefore, we have no choice than to use what? Addition law of logarithm. So this is going to give us, I'll pick one of the logs, they are in the same base, that's why no base was given there. So you can assume it to be base 10 or any other the same base. Okay, so I'm going to work out something simultaneously here. And what is that? You notice that the power of this number here and the power of this number here, they are the same. And if they are the same, one can apply power law of indices. Remember, we learned from indices that you have x raised to power a times y raised to power a is the same as x times y in bracket all raised to power a. You factorize the common power because power is distributive over what? Multiplication. Therefore, coming over here, I can do that once. And as I'm doing that, I want you to observe something. This bracket is difference of two squares. It's difference of two squares. So what stops me of writing it as x minus 1 times x plus 1? This term is the same as this x squared minus 1. We actually met something like this under partial fraction, you know, and even polynomial. Then it will be multiplied by x plus 1 all over x minus 1. That is the second bracket. The second number in front of this log. Then everything will be raised to power what? Half. So look at that expression. Is that okay? I broke down this using difference of two squares. I know by addition law of logarithm, I'm meant to multiply this number by this number in front of this log. Now they have common power. I factorized the power out and then expanded this. I factorized it to difference of two squares. Now having done that, do you notice that this term, x minus 1, is numerator there? It will cancel this x minus 1 in the denominator. And once it cancels, this will now give us log of x plus 1, which will be left from here. This is times. And here I have x plus 1 as well too. Then all raised to power what? 1/2. And then this will give us log, the same term in the bracket here, so it's going to be x plus 1. As we're multiplying that, it will be raised to power 2. Then power half outside. Once again, by power law of indices, the powers that multiply out, is that not so? So once they multiply, these 2 will cancel these 2. Therefore, the result of the problem, log square root of x squared minus 1 plus 1/2 times log, open bracket, open another one, x plus 1, all over x minus 1, good, is equal to, you write it there, equal to log x plus 1, then closed. Because you have power 1 here, so it's the same as this log x plus 1. And this becomes the solution to this problem on the board.